company building quantum computers with light. Xanadu. Explained quantum computing has long been described as the next technological revolution, a technology capable of solving problems that would take today's most powerful supercomputers thousands or even millions of years to complete. But while most quantum computers rely on superconducting circuits or trapped ions, one company is taking a very different approach. They're building quantum computers using light, and that company is Xanadu. Founded in Canada in 2016, Xanadu is one of the world's leading quantum computing companies and has attracted significant attention for its unique photonic approach to quantum computing. So what exactly does that mean? To understand why Xanadu is different, we first need to understand the challenge facing quantum computing. Traditional computers process information using bits, which can exist as either a 0 or a 1. Quantum computers use quantum bits, or qubits, which can exist in multiple states simultaneously thanks to a phenomenon known as superposition. This allows quantum computers to process enormous numbers of possibilities at the same time, potentially unlocking breakthroughs in areas such as artificial intelligence, pharmaceutical research, logistics, financial modeling, and materials science. The problem is that quantum systems are incredibly fragile. Most quantum computers require temperatures colder than outer space and highly specialized environments to function. Even tiny disturbances can cause errors and destroy calculations. This is where Xanadu's approach becomes particularly interesting. Instead of using superconducting circuits, Xanadu uses photons, individual particles of light, as the carriers of quantum information. These photons travel through highly sophisticated optical circuits, allowing quantum calculations to be performed using light itself. The potential advantages are significant. Photons naturally move quickly, generate very little heat, and are less susceptible to certain forms of environmental interference. This could make photonic quantum computers easier to scale than some competing technologies. In simple terms, while many companies are trying to build larger quantum processors by adding more traditional qubits, Xanadu is attempting to build an entirely different kind of quantum architecture. One of the company's major milestones came with the development of Borealis, a photonic quantum computer designed to demonstrate quantum computational advantage. Quantum advantage refers to the point where a quantum machine performs a task beyond the practical capabilities of a classical computer. While the field continues to debate the significance of various demonstrations, Borealis placed Xanadu firmly among the leading innovators in quantum computing. But the company's ambitions extend beyond hardware. Xanadu has also developed open-source quantum software platforms designed to make quantum computing more accessible to researchers and developers. The idea is simple. If quantum computing is going to become a transformative technology, there needs to be an ecosystem of software, algorithms, and developers ready to take advantage of it. In many ways, we're currently witnessing a stage similar to the early days of classical computing, when researchers were still figuring out how future applications would work. Of course, significant challenges remain. Quantum computing is still in its infancy. Error correction, scalability, manufacturing complexity, and commercial viability are all major hurdles facing the industry. No company, including Xanadu, has fully solved these challenges yet, but what makes Xanadu particularly fascinating is that they're not simply trying to improve existing quantum architectures. They are betting that light itself may provide the foundation for the next generation of quantum computers. If they're right, photonic quantum computing could offer a pathway toward machines capable of tackling problems that are currently impossible to solve, whether it's accelerating drug discovery, optimizing global supply chains, developing advanced materials, or powering future artificial intelligence systems. The implications could be enormous. Quantum computing remains one of the most ambitious technological pursuits of our time, and among the companies pushing the boundaries of what's possible, Xanadu is certainly one to watch. The future of computing may not be built from silicon alone, it may be built from